Hello, everybody. It is 10 o'clock, my time. No idea what time it is your time. And we're going to get started. Apologies for having missed last week, or Saturday. I dislocated my knee a couple of weeks ago and had to go to a nearby town, to an orthopedic clinic, and get a special x-ray. MRI done on my knee. So, and then we go see the doctor again tomorrow, and we'll find out what happened. So, yeah, apologies for that. But we're back today to pick up where we left off last Tuesday, working on the rustling exercises still. I had thought this might... I had no idea how long this was going to take when I started it. I certainly didn't think it was going to take 7 or more episodes to get through, but I've learned a ton and it's been really interesting, so I'm not at all unhappy. We are very near the end, although I may make some choices today that prevent us from reaching the end because, why not? So we'll see what people are interested in when we get there. But we're near the end. We're in the middle of some conversion exercises. There was a TryFrom conversion exercise that I got really bogged down on Tuesday last week, and I think we spent over 45 minutes on it, and I was clearly just not being smart. I was just like programming with my hands and not my brain, and that did not go well. And so I actually had to look at that problem afterwards and got it sort of cleaned up in my head. So we'll come back to that, get that done. There's the potential, so we'll probably do some refactoring there as well, because I think that part of my mistake is I was trying to do too much at once, and I think it works better if I sort of was fairly straightforward about it and then cleaned it up after the fact with some refactoring. So we're going to do that. And then if people are interested, or at least aren't opposed, I might actually try some performance metrics. Because one thing I was curious about when I got to the sort of worked out the basic setup is the refactored code, I would argue, is definitely cleaner and shorter, but it may be less efficient. And I don't know to what degree that is or isn't true, but we have tools that will tell us these things. And so I could totally run the criterion library, use that to do some testing, and see if that in fact, if my refactoring made things non-trivially slower. And that would be an interesting thing to explore. If we're not interested in doing it today, I might do it on my own outside of the stream. But if people are up for it, we could have a go at that. But that would definitely slow us down and prevent us from finishing the rustling exercises. After conversions, if we get there, there's a couple of advanced error exercises, and then we'd be done with rustlings. If we skip the performance and we finish the rustlings, we might start an actual project. That would be the other option, is I've got a project that I want to write in Rust, and we might give that a shot. But I don't know. We'll see. So let's actually go back to the conversion exercise where I got totally lost on Tuesday last week. Get that fixed, and then we'll see where we go from there. So thanks a lot, and here we go. And so here's the exercise where I got completely bogged down on Tuesday last week. Also, we're in the middle of like a god-awful heat wave, and so there's a bunch of fans running in the house. I can turn fans down or off. If there's like a white noise issue, let me know. I don't know how much that's coming across through the mic or not. So this is basically, it's a conversion exercise. It's in fact, I think, the last conversion No, there's one more conversion exercise after this. And it's focusing on the TryFrom trait in Rust. When you convert from one thing to another, in some cases the conversion is guaranteed to make sense and work. But there are other circumstances where the conversion isn't guaranteed to make sense, and it might fail. And a TryFrom gives you the flexibility of doing conversions where there might be failure and handling the failure gracefully. In particular, TryFrom conversions return a result. Instead of just returning the converted value, they return a result type where the OK variant is, hey, it converted fine and here's your value. And the error variant is, well, something happened and here's the bad thing that happened. And so that's actually a very cool construct, and I like that. It wasn't something I was familiar with when we got here a week ago. And so they illustrate this in this exercise. They have a struct color that has three components, a red, green, and blue, each of which is a U8. So we're doing 24-bit color here, where we have 3 bytes, 3 U8s, and they're unsigned bytes, so they're 0 to 255. So we get this nice, clean, representation of a 24-bit color. And we're going to be converting from, as we see here, groups of 3 i16s, so 16-bit integers. And an i16 isn't guaranteed to fit into a U8. An i16 can have negative values, which do weird things. It can have values that are bigger than 255, which can do weird things. And so that's part of why we're going to be using TryFrom here to do the conversion, so that we have the option of generating an error. And they provide an error type here, which is into color error, which has 2 variants. Int conversion down here is the error that we'll use if the i16 to U8 fails. Bad len comes up in the third. There are 3 versions of this conversion. So let's actually talk about those. The first version takes a tuple of 3 i16s and makes a color. The second takes an array of 3 i16s and makes a color. Both of those could generate the int conversion error if any of those i16s don't play nice. The last one takes a slice of i16s and generates a color. And this is a little more tricky because this slice could have any non-negative length. It could have 0 values, it could have 1, 2, 3, which is what we want, 4, 5, 6, a billion, whatever, right? So here we can't say in the type system how long this is, in the way that in arrays we can say this is an array of exactly 3 values, or in the tuple we say this is a tuple of exactly 3 values. Here in the slice, this is a slice that contains some i16s, but we don't know how big it is, so we have no idea. So if it's the wrong size, that's where we'll return this bad len error in our result type. Okay, does that all make sense? Questions? Okay, then so let's actually just start. And I'm going to try to be as simplistic as possible at the beginning to avoid some of the problems I ran into last week. And then we'll do some refactoring to clean up what will be some obviously simplistic choices. Okay. So we're going to start with this tuple version. The tuple version's nice because we have exactly the right number of values. Oh, actually, I was gonna. At the moment, it doesn't compile because none of these return anything, and that makes the errors not as helpful as I would like. So I'm gonna actually use the to-do macro on all of these, so that it compiles and we get instead sort of more focused responses. In particular, we can find out if some of the tests pass or if none of the tests pass. So right now, all 14 tests fail. That's what we would expect. Okay. So here we've got 3 I16s in a tuple, and we want to generate a color object. Well, we need to convert each of these I16s into an I8. Turns out there is a TryFrom that we can use to do that. So we could say, let red result equals tuple 0. So in Rust, if you have a tuple, dot 0 is the first item in the tuple, dot 1 is the second, dot 2 is the third. And we want to say the TryFrom syntax is boom. So we're saying we want to convert from this, whatever this is, which in our case is an I16, to the type provided before the double colon. So we're saying we're providing a conversion from this to that. And the TryFrom implementation that we're doing here is going to let us do color double colon and then a tuple of 3 I16s. And we can see that down here in main. So we have color double colon TryFrom, and it's taking a tuple of 3 I16s, and that's going to call this TryFrom trait implementation here. And so we can use TryFrom inside our TryFrom, but it's a different TryFrom. It's a TryFrom that goes from I16s to a single U8, a single I16 to a single U8, and we can use that as a tool in going from 3 I16s to a color that contains 3 U8s. Okay. So we can do that, and then we can do the same thing with green, and we can do the same thing with blue. And this repetition annoys me and is one of the things that led me to want to do some refactoring. And I got ahead of myself last week into the refactoring too early and got everything got all bogged down. But we will come back to this. I find these 3 lines definitely annoying. Now, the trick is I can't just say color, well, it would be an OK because this returns a result. I can't say, it would be red colon red result, green colon green result, and blue colon blue result. I can't do that because I get type issues. I was expecting this to be a U8, but as it says here, it found a result because, as my name implies, this TryFrom, it returns a result in the same way that the TryFrom we're defining returns a result. So this is going to be a result type that's going to be either OK if we were able to convert this I16 to a U8, but it could be an error variant if that didn't work. Sigh. So we got to do something about that. If we think about it, there are 8 possible combinations of OKs and errors here, because each one of these 3 conversions could generate either an OK or an error. And so we have 8 possible combinations of those. We definitely don't want to do anything that would just list all 8 of them. That would be seriously gross. Luckily, we can use match here. And this is going to be a little weird, but we can do it. And this will maybe change later. Maybe not. I don't know. But we could say match against that tuple. So we can, in a match, we can take multiple values, put them in a tuple, and get a match against that tuple. So we're, in some sense, sort of saying, let's look at all 3 of them as a group instead of saying, let's look at them one at a time. And because all we care about really is the one where they're all okay versus everything else. So we can say, okay, red, okay, green, okay, blue, and do something. Or we can have anything. And the underscore will match any other case, which is the 7 other options. They all failed. The first one succeeded. The next 2 failed. The first and the last failed, and the middle succeeded. All of those will just get caught up in here. And so we avoid like a huge pile of if-then-else nonsense. And that seems like a good thing. Here, these okays, when they're all okay, these red, green, and blues will be assigned to... actually, it does not need to be paren underscore underscore underscore. It turns out that underscore matches anything, literally, including any tuple. That wasn't obvious to me. To be honest with you, I had no idea that would work. But it turns, having done this earlier, that does actually work. So we don't need. We could, there would be nothing wrong, since we know this is a tuple of 3 things. We could totally do this. There's nothing wrong with that. But we can also get away with a single underscore. So I'll just leave it as single underscore for now, and we could come back to it and play with it if we wanted to. So thanks. Good question. So the red, green, and blue will match the actual U8s that were generated in these conversions when the conversion succeeded. So here I can actually grab this guy, and put it here. So that's a little unwieldy. Let me actually close that over so we can see everything. But it worked. So if we match this tuple, then we're going to make an OK variant, and this OK variant attaches to this result up here, whereas these OK variants came from these TryFroms down here. And this OK variant is going to contain a color, which has a red. Oh, and now these are all wrong. So it would actually be red, because we want this value. But if the name of the field and the value are the same, we can just say red. So here we can just simplify this to red, green, and blue. And now this, of course, is a disaster. So actually, if I do this, I think something will happen. Yeah, so 1 test passes. Woo! So the test that is actually checking for everything being okay, that passed. This still fails. So tuple, out of range negative, out of range positive, and sum, these 3 tests all fail, presumably because we've got something that needs to happen here. So here we're going to have to return an error, because that's what the result type is going to require. And we need to give it an error, which is this into color error. So we say here self error, which is actually just a reference to this type error here. So we're returning an int color error, int color error. And we need to return, that's a type. So it's an enum. and we need to return a particular value, which is one of its variants, which in this case is the int conversion variant. And now I think our tuple test will pass. Yay, they do! So our tuple tests all pass, and the failures are now array and slice tests. And if we scroll up past all this stuff, we see that we get OKs on our 4 tuple tests. So, huzzah! The tuple works. Get rid of my to-do there. And we did a thing! And this does show that we can get away with the single underscore here. Just to check it. Oops, we should presumably be able to also do this, which this will only match if we actually have a tuple of 3 things, and it says, I don't care what those 3 things are, but it has to have at least that structure. Whereas in my version, we're saying we really don't care at all. It could be anything. It could be a vac, a string, doesn't matter. We would match this case. Now we know none of those are happening because we know we have a tuple of 3 things, but we don't really need that information here. So, okay. Questions? Doodly-doo, doodly-doo. Okay, then let's move on to the array one, which will be also reasonably simple. Oh, actually, there was one thing I was going to do up here on the tuple one. I really don't like these tuple dots. That's not super readable. It's very error prone. If you inadvertently had a 2 instead of a 1 or something, it would be very easy to make that mistake, copy pasting, for example, and hard to see. Your brain tends to just miss stuff like that. So I'm not thrilled about these. And it turns out we can actually here, instead of the word tuple, we can in fact do pattern matching right here in the argument. So we can provide a tuple with 3 names here in the argument, and this will match when the call gets made. This will assign this I16 to the variable red, this I16 to green, and this I16 to blue. And now we can change these to red, green, and blue instead of those tuple things. And that would be less likely to just be misread. Green, it's harder to mistake green for blue as a word than it is to mistake tuple 1 for tuple 2 in a skim. So I think that's an improvement on that. And notice shadowing means that this is now a new red, not the, so this red here doesn't refer to this red here. It's its own new thing. And so we can use it to capture the U8 and then put that in here. Okay. So let's move on to the array implementation. It's going to look almost identical. In fact, if we do the same pattern matching trick, but with the array here instead of the tuple, we can copy all of this identically. Now that's terrible. I mean, from a clean code refactoring perspective, that is nasty because we have literally copied the entire function body from here to here. So we have duplicated all of this logic. This is not good, and we will clean that up when we get to the refactoring. But again, I think one of the mistakes I made last week was trying to do too much at once. So I'm going to focus today on getting it to work, and then we will focus on getting it clean. So the classic red-green refactor pattern, it's red because the tests are failing. We want to make the test pass, green, and then refactor. And I was kind of muddling up the green and the refactor phases last week in my head. So we're just going to do what needs to be done, the simplest thing that could possibly work, even though it's ugly. and get that to the test to pass, and then we'll tidy it up. So that actually takes care of 8 of our tests, and all we have left now is the slice. I didn't realize you could do a pattern match on an array like this, but thinking about it, like an array and a tuple are awfully similar. The biggest difference in some ways is that every element of an array has to have the same type, whereas the elements of a tuple can have different types. But in a lot of ways, because an array is fixed size and known size at compile time, there's no real reason you couldn't do pattern matching like that. Turns out you can, then we're good. Okay, so let's get to the slice. Slice is where it gets weird, because we can't pattern match like this, partly because we don't know how long the slice is. So we need to check that the slice has the right length, namely 3. If it does, we can extract the 3 elements, and then we have basically the same code pattern. So we'll be able to just copy and paste this again after we've sort of gotten the 3 pieces out. So let's first do the length check. So if slice.length doesn't equal 3. So if the slice has the wrong length, it's less than 3 or it's greater than 3, then we're going to want to return an error here. And this is where that bad len variant comes in. So here we would say, if the slice doesn't have the right length, let's return right away. No point in messing around, and we'll return an error that contains a bad len variant of the into error color, and that will actually pass some tests. So we it's not. I think it's just len. I think I let the autocomplete trick me. Yes. So we used to have 6 failing tests. Now we only have 4. So just doing that simple thing allowed these 2 slice tests to pass. So slice excess length, so that would be a slice that's too long, and slice insufficient length, a slice that's too short. It's actually not super clear from the write-up that you're supposed to return an error if the slice is too long. And you could imagine a universe where you don't cause people to cause an error if the slice is too long. Maybe just ignore the other elements. But they have a test that explicitly expects to fail if the slice is too big. So it makes sense. We'll go ahead and play with that. And return the bad len if the length is anything other than 3. Yeah, right. We could have just been like, if there were 7 values, use the first 3 and ignore the other 4. But their tests suggest that's not what they meant. So we'll roll with the tests. Okay. So once we know, at this point we know the slice has length 3, right? That's the only way we could have gotten to the rest of the code, if the slice has length 3. So we can say let red be slice 0, and let green be slice 1, let blue be slice 2. And so we can get the 3 values, and at this point, actually, we can then just grab all of this. Oops, I'll leave that there for now. Actually, I'll get rid of that because I want my match to return. Yay! So I'm definitely not going to mark this as done, but we actually pass all the tests. So the thing that took me, I spent 45 minutes on and wasn't done with even the first part, I think, or the second part last time, we're all done in well under half an hour. Now I'm going to clean it up, but it works, right? So the advantage of actually just trying to get it done. Now as I said, there are, well, hello there, sir, ma'am, actually, person. There is this nasty duplication. We now have 3 copies of exactly the same 7 lines of code. So we have them here, here, and after some other stuff here. And that's not very good. We don't want that. We would like to tidy that up. So let's actually do some refactoring to clean that up. It seems to make sense. Notice that because both the tuple and the array version literally have exactly the same body, it would seem to make sense to use one of them as the thing that we call from the other places. So we want one copy of this code, and we want everybody else to call a conversion function to run that one copy of the code. We could have the tuple one be the thing everybody calls, or the array one be the thing that everybody calls. It clearly doesn't make sense to have the slice one be the one everybody calls, because the slice has got this slice-specific logic that doesn't really make sense for the other 2 options. So it doesn't make sense to have them call this, but it would make sense for the slice to call one of them here. We could do it either way. I think it really doesn't make a ton of difference at this point. There isn't a lot of reason to choose. It could be an independent thing on the color type itself. That's a possibility. So we could have, for example, a function that just takes red, green, and blue, and then all 3 of these just call that. Actually, do I like that better? Maybe I do, actually. Do I think that's a better option? I'm going to say no at the moment, although I'm not convinced I'm right. I'm just making a choice. And the reason, okay, so I'm looking ahead a little bit, which is dangerous and what got me in trouble last week. So, the reason I'm going to not do that, and the reason I was going to choose the array version over the tuple version, is I also don't like this very much. I don't like having 3 separate calls to try from here, and I'd really rather use a map function to map over some structure and say convert all of these elements from a I-16 to a U8 for me, instead of doing it as 3 separate calls. Now this is part of where I get into the performance questions, and if we're interested in looking at that, we might explore kind of what the performance implications are of mapping, because it might be non-trivial, I don't know, because there's some type conversion that has to happen. Whereas I think your idea of having it be an independent function on color might actually be more efficient. But for the moment, I'm going to actually stick with this version. I'm going to use the array as my base method and have everybody call it, and then because arrays I can map over them. I can't map over a tuple, because a tuple, the values can be, the elements of a tuple can have different types, so you can't map over it because you wouldn't know what the type of the function you were mapping needed to be. You'd have this weird function that needs to take an I-16 and a string and a duck and a goose, and it wouldn't know what to do. So we can't map over a tuple, but we can map over an array because all the elements of an array have the same type. So I'm going to actually have everybody convert to an array and call the array version. And then we'll see where we go from there. And maybe we'll come back to the independent type option, because that would be interesting to see how that would work out. So, but let's, for starters, let's just go with the array thing. So the easy one is to change the tuple to use the array, because I can literally here just say color TryFrom and pass an array of red, green, and blue. Wow. Boom. And so this takes this tuple, basically rewrites it as an array, and calls color TryFrom, and we're finished. And if we had that helper function that you were suggesting, then it would look something like TryFrom red comma green comma blue without the square brackets, basically. So it wouldn't change this very much. But it might still be a little cleaner. And we presumably pay something to construct this array. Whereas if we pass the three values as just separate arguments, we wouldn't do that array construction. Now, I don't know if the compiler is smart enough to basically optimize out the array construction and realize that this is being called where it has a pattern match here, and it just says, oh, look, I don't need to actually construct an array and destruct an array. I'll just like assign these variables and move on. I don't know if the compiler is smart enough to do that or not. If it's not and the array gets constructed, then this has a small cost associated with it. But the tests all pass, life is good, and that takes care of this. And down here, we can get the same thing exactly, right? We're basically just going to take this and put it right here and get rid of all of this code. Okay, so now everything passes, but we don't have nearly as much duplicated code. So we've replaced 7 lines with 1 here, and we've sort of replaced the bottom 7 lines with 1 line here. So we've removed like 12 lines of code and avoided duplicating that logic. So that's actually pretty nifty. Okay, now further refactoring. So here's where I would like to map over that array. And this is going to get a little complicated, and maybe it's not even really worth it, especially for a simple 3-element array. The machinery that I'm spinning up to avoid this small bit of duplication probably adds to the overall runtime, does a lot of conversion, may not actually really be worth it. But I'm curious. I mean, A, because I'm doing this to kind of get better at Rust, it gives me a chance to practice some stuff. And B, I would like to do a performance test and see if it actually does cost us something to do the map from a performance perspective. So instead of extracting red, green, and blue here, I would like to return this to tuple, and let's comment that out for now. I want to say something like let conversion result be tuple dot map. So I can map across a tuple, and so I'm going to have a value, which I'll call V, and that value is either going to be the red, the green, or the blue component of the tuple. And so I'm going to want to do U8 TryFrom V. And so if I start there, that's going to give me a conversion result. In fact, actually, that could be exactly this, because it's going to be a tuple of 3 results. And, oh, hey, that didn't work. Oh, right. That doesn't work because oh, we're in array land. Duh. This would be an array, not a tuple. Expected an array of 3 elements, and yeah, there we go. Okay, so that works. And interestingly, I'm actually using a tuple still here. This probably ought to be an array, which I'm guessing I can still do. Oh, and then this is going to have to be an array. That's one of the disadvantages of copy-paste. I probably should have changed this to an array from the beginning, because by using a tuple, it had to take what was an array and reconstruct it as a tuple. Here it stays an array all the way through, and I would guess that, again, the optimizer might be able to minimize the array construction, deconstruction that happens as a result of that. So that worked. And that wasn't too bad. Now, actually, that's pretty decent. And then we don't have to do anything to either of the other two. Huh. I think when I had played with it before, I had ended up, yeah, so this was pretty easy. And actually notice this has made this shorter. We now have 1 line here instead of 3. Whether it's more readable, I think you could probably have an argument about that. But we definitely have, I think, shortened it up, and we've avoided repeating this 3 times. It now only happens once, which I like that better. Now the trick actually is down here. So there's really nothing to do here. This is still, I think, good. The trick is here, could we convert the slice directly into an array and then pass that array in instead of this sort of by hand deconstruction and reconstruction? And it turns out we can. There is a TryFrom that will take a slice and turn it into an array. So I think we ought to be able to do something like, I'm going to comment all of this out. We ought to be able to say, let A be I16, 3, and I need to put that in angle brackets for syntactic reasons. TryFrom slice. And then color TryFrom A. So this will try to convert this slice into this type, an array of 3 I-16s, and if this is going to then be a result, so it's not really the array, so that's going to be array result, and that's going to be a result that's going to have either an array of 3 I-16s, or it's going to have an error of some sort. I think that's... Oh, and I change this to A. Now, it's error. No, it's not even that. It's just the type. So I can just say it's going to have some error type. And doesn't like this. Oh, it doesn't like this because this is a result, not an array type. So we're going to have to do something with the result here. And the problem is, so one thing we could try to do is we could say question mark here, change this name to array, and change this name to array, and then the question mark is going to panic if we don't have the right thing. Boy, it's very not happy. Oh, yeah. So, question mark. If this had succeeded, the question mark is going to extract the array of I-16s, and this isn't a result anymore. That typing is completely wrong. So it will just say that. And now we'll still get a bunch of errors. Yeah, but we're down to just one. Okay. So the question mark says, hey, if you're an OK, we'll just take the value out and we'll assign it. Life is good. However, if there is an error, we will return that error right away. The problem is that error has to be of this type. TryFrom, if there's going to be an error, it's going to be of this type, which is an into color error. So if we're going to use question mark, the error thing has to be an into color error. And what this is telling us, and I found this confusing when I first saw it, I didn't really understand how to read it. What this is actually telling us is that we wanted an into color error, but what we got was a TryFrom slice error. So if this TryFrom fails, it's going to return a TryFrom slice error, which only happens if the slice was the wrong length. Since we're converting a slice to an array, if that slice is too short or too long, then we'll get a TryFrom slice error. And this error, the compiler error, is happening because this is the wrong sort of error, and if we end up returning that error with question mark, it'll be a TryFrom slice error, but we said it was going to be an into color error, so it doesn't work. So we can fix that by mapping the error. So map error takes an error, and we don't really care what it is, and returns a new error, which in this case needs to be an into color error bad len. And now this will actually compile and run and pass. So what's going on? This converts the kind of error we got, if there is one, into the kind of error we want. if there was one. If the value from this, if the result that we get here is an OK variant, map error leaves it alone. Thanks. It'll leave the OK variant alone. If there's an error variant, though, it will map it from whatever it was to whatever we ask it to be. And so we're going to turn it into a bad len. And so this will now return a bad len if our slice had the wrong length. If it had the right length, it will convert it into an array. And at that point, we can just call color TryFrom. And we're good to go. Boom, boom, sploop. And that is pretty awesome. Zippity-doo-dah. And so that actually is a pretty clean version of this, actually. I think that's about as short as I know how to make it. In fact, I'm going to remove that line. I don't think that line's doing anything. And in fact, I'm not 100% sure that line's doing a whole lot. Yeah, I think we'll leave it. Take that line out too. So we've got, this is one line, this is two lines, and this is the actual logic, which turns out to be 5 lines. And so that looks pretty nice. The thing that worries is the wrong word. The thing that I could imagine somebody being concerned about is the performance. Because there's this little, and this is probably teeny, and I would hope that a good compiler optimization would actually make it go away, but there might be a small cost to deconstructing this tuple and constructing this array. Maybe, I don't know. There is almost certainly some cost to doing this, here, this convert TryFrom here. But I don't know. I mean, it's not obvious that it's any worse than having the if check followed by extracting the 3 pieces. So this is actually cleaner than the version that I had worked out before. This is one of the advantages of doing the same problem like 6 times, is oddly enough, you often get better at it. My version earlier, it had more going on, and so I've been a little more concerned about the performance side of it. I'm actually less concerned about the performance side of it here. And so the question, I guess, for the audience is, we could call this done and move on to the next exercise, and I would be totally fine with that. Or if we wanted like engage in some more flailing, and there would be more flailing involved because I'd be using some stuff I don't know as well, we could use the criterion library to actually run performance tests on these different versions and see if there is a measurable difference between them. I had originally thought that would be a good idea. I'm a little less inspired by it at the moment. And both because I think there's probably less in it than there would have been before, because I think I was doing more conversion and weirdness in my other version. But also, I don't know if I would trust the results a lot with the Twitch streaming stuff running on the same machine. It's hard to know kind of how the Twitch and the benchmarking might interact. So I might actually either drop the idea of doing the performance check or do it outside of the stream when the streaming software isn't sort of interfering. However, if anybody here is like, man, I really want to do the performance thing, let me know. Speak up. Otherwise, I'll call this thing done and we'll move on to the next exercise. Going. gone. We're going to mark this thing as finished. I am done. Yeah, I agree completely. That it's so small, and I assume the compiler optimizations will make a lot of this go away. So I'm totally fine with just setting that aside. So I'm not sure how to read that. Is that a you disagree? Patatas del Papa? Not sure. But let's press on. So we have one more conversion exercise. AsRef mute. Oh, gotcha. Thank you. I am still the whole emoticon thing in Twitch. So in all honest fairness and full transparency, I'd never really used Twitch before as a viewer before I started streaming on it. So, which is really not the cool way to do things. I appreciate that. But it means that like I'm kind of clueless about emoticons. Our child is much more into Twitch than I am, and has been explaining some things to me. Yeah, so feedback like that, always good. Okay, so this is the last conversion exercise, and then there'll be 2 advanced error exercises, and then we would be done. So we might finish this today if I don't get lost in these things again. AsRef and AsMute allow for cheap reference-to-reference conversions. We've got several things. Looks like we have 2 things we have to implement. Byte counter, which takes some T and returns a U size, and char counter, which does something similar. So byte counter, we want to obtain the number of bytes in the given argument, add the AsRef trait appropriately as a trait bound. So this doesn't compile because AsRef doesn't have, there isn't an AsRef on T. So T is an argument, and we're calling T.AsRef, and it's like, I don't have an AsRef. So we need to say that T provides the AsRef trait. I don't remember the syntax for that. I know I've seen this like a zillion times. T, I guess we could just grab one of these guys, and we'll no doubt see examples of how that syntax works. T:\AsRef. Okay, well, that's a thing. So we want T:\AsRef, and AsRef was a parameterized type, and as bytes. Who knows how to do as bytes? Rust as bytes. A string knows how to do as bytes, but I don't. Oh. Okay, but I am doing. So do I turn it into a string? That seems weird. Oh, wow. So many errors. Items from traits. So maybe I don't need to say string here. Maybe I can get away with just AsRef. and then we would say T AsRef. Is it that simple? No, of course not. Oh, it does want a generic argument. Great. And it's anything that is sized. Interesting. So do I need another generic argument? Is that the right answer here? No, doesn't like that. Probably doesn't want that. Oh, I'm missing an angle bracket. That's my problem. Okay, now where are we? Didn't like U size. Oh, that's probably because I didn't say anywhere. No, that's the problem. This trait takes one generic argument, but 0 were defined. Blar? Is that not a generic argument? Okay, so the question mark size means it can be a non-size type like U8. Oh, interesting. So I've got a hint here that I was close on the string type. So let's go back to that. What does the compiler yell at? Oh, it doesn't yell at all. So let's try that and at least see, what do we get? Okay, so we get some, we got all kinds of grumpy. AsRef string is not implemented for str. Char counter S. Oh, it's not a string, it's a stir. I bet. Because that's going to be that S down there is going to be a stir. Okay. Whoa, so many errors. Oh, lifetimes. Oh my god. Yeah, fine. Why do I need a lifetime? Because this reference is going to be a reference to this slice, and that reference can't live any longer than the slice lives. But I would have thought by the time we got to count, we would have used the reference and not need it anymore. It's not clear to me why I need a lifetime there. I'm right about the lifetimes? Well, it's still grumpy. AsRef static stir is not implemented for stir. Oh, so yeah, it wants a lifetime there when it does the print. Huh. Oh. Try this without the ampersand? Okay, that's weird. So, the ref gives me the ampersand. So this AsRef, we're talking about a reference to what? To a collection of characters, things, characters in the case of this, and with the ampersand I was saying a reference to the stir, and I didn't want that. I just wanted a reference to the stir. So this is giving me essentially the ampersand. So this would be ampersand stir, but this is taking care of the ampersand part. Gotcha. So T here is going to be ampersand stir in this instance, and that can be a reference to a stir, and so life is good. Interesting. Okay. So let me see if I actually understand this. So S is an ampersand stir, and actually is being allocated on the stack in this instance, I think. So we're passing that reference to that collection of characters to char counter and to byte counter. So byte counter takes an argument of type T. T needs to be a reference to a stir, and that's necessary so we can get this AsRef thing. Now, AsRef, as bytes. I'm not sure I fully grok what AsRef is doing. So AsRef converts between mutable references. Oh, sorry. AsRef, blah, blah, blah. In trait bounds, we accept arguments for different types as long as they can be converted. Oh, and this did say str right there. This is what I probably should have actually read this instead of been in a hurry to get back to the code. Yeah. Yeah, so AsRef is as ampersand self to ampersand T. Oh yeah, sure. Okay, so it's taking a reference to self and turning it into a reference to some other type. So in our case, it's taking yeah, let's have to look at the test. That would be useful. Yeah, because that is kind of awkward. So they take a ampersand stir and they call it with the two counters and say they should be different. And that's presumably because characters aren't the same as bytes, because we're in Unicode land to support things like that. We assert, oh, interestingly, so here they are the same because these are all ASCII, and so the number of characters will equal the number of bytes. Now here we get a string from this character, and we clone and call char counter, and it should be different than byte counter. So we can pass a string in, because a string can be can be read as a ref to a string slice. So that's okay. And we had to clone because this consumes this argument, and if we didn't clone, we wouldn't be able to use S again over here. So we had to clone it because we consume it here. We don't borrow it. And then the last test is we also convert a string, but again without the accent, and now these two things are the same. So, okay. So that's where there's actually some conversion happening. So when it was just an ampersand stir, this didn't really do anything because we were taking an ampersand stir and turning it into an ampersand stir. But because we can take a capital S string and convert it to an ampersand stir, we can pass a capital S string here, and AsRef is turning a reference to, no, a string, sorry, into a reference to stir. So this converts it into an ampersand stir, and then we can call asbytes on that, or chars. Oh, we can call asbytes on that or chars on that, either one, and then both of those. Oh, bytes must be a different type than chars in stir. So Rust stir. So actually, it was right at it. Oh, actually, I probably wanted this, right? And as bytes takes a slice and returns a reference to an array of U8s as bytes, and then chars is the other one, and that returns a iterator. And so that's why we have the two different calls here, because that's an array. We can call len on it directly, and we will be able to get the length. But here, because this chars is an iterator, we had called count on the iterator to find out how long it was. Woo! Okay, I think I actually sort of understand. Thank you for all of the help and suggestions, peeps. Appreciate it. Any other comments or questions before we mark this thing as done and move on? And then I guess it's worth noting that there is an asmute. If you need a mutable reference, you would presumably use asmute instead of AsRef. And we don't need a mutable reference because we're just counting things, not changing things. Okay. We are done with this one, and that finishes the conversion exercises. Yay! And now there's two advanced error exercises. Who knows what these are going to be like? We're going to find out. Advanced errors 1. Remember back in error 6, we had multiple mapping functions so we could translate lower level errors into our custom error type using map error. Oh. What if we could use the question mark operator directly instead? Oh. Well, I think I'm about to learn something because I don't really immediately know what that's telling me. So we've got a custom error type used in from stir down below. So a parse pos non-zero error. And so we can have a creation error and a parse int error. And we're gonna have to mess with this from implementation. Here's a from stir. So from stir takes a string slice, returns a result, and we say s.parse question mark. And that gives us an I64, or throws a parse pos non-zero error. Does it really? I would have thought parse would have not returned this custom error. And assuming that that didn't fail, then we'll return an OK, calling positive non-zero integer :new x. Oh, that's down here. And we've got our new that constructs that. And our new potentially returns a creation error, which happens if the value we're given is either negative or 0. So we match the value. If it's less than 0, we return the negative. If it's equal to 0, we return the 0. Others return OK. And we convert this this I-64 into a U-64. Okay. That part I get. So that does this. Now this question mark, so these are returning creation errors. So new potentially returns a creation error. And this question mark, yeah, so this is the thing that's weird, is these question marks return a different type of error than the type of error we were expecting. And so that seems to be a problem. And there's some disagreement in the chat about using map error versus from error. Oh, and that's what's happening. I get it. Okay. I didn't twig that this was from an error to an error. I understand what's happening. And I had this thought actually related to one of the other, actually the earlier TryFrom exercise. I'd had the thought of actually, instead of doing the map error, actually having an explicit conversion from the one error to the other, because that's actually what the compiler suggests. That the compiler, when you get an error because you have the wrong kind of, when the compiler fails because you have the wrong kind of error, it actually suggests that it's looking for a from. So I was like, oh, I should maybe think about doing that. Well, now I get a chance to try it. And yeah, I don't know. I don't have enough experience to say. I think I agree with Wagafa that if there were a lot of calls to map error, they do clutter things up, and if you just had the one from, it might be clean things up some. On the other hand, you've got to figure out how this thing is magically being converted. With the map error, it's explicit. You know exactly what's happening. If you're using from, it's like some voodoo somewhere else just converted this one kind of error to another, and you're like, how did that happen? So I can definitely see arguments for both versions of it. Okay, so we want to convert from a parse pos non-zero error, no, from a creation error to a parse pos. Yeah, you do define the voodoo in from, but you got to figure out where that is. And if you're using it in one place and that definition was somewhere else, it can be harder to figure out kind of where that definition happened. Whereas if you have the map error, it's completely obvious that right in that place we took this thing and made it a that thing. Like it's right there when it happened, as opposed to we implemented a thing somewhere and I don't know where that happened. And so, and I've certainly run into that in learning Rust. There are places where conversions happen, and as a new person especially, I didn't know where that was occurring. And so, but I also, if you're more experienced, maybe it's less of a thing. Like you get used to knowing where to look for stuff as you get better at it. And that's true for anything, right? So, okay. So here we want to convert from a creation error to a parse non-pos zero error. So we just want to return a parse pos non-zero error, and we want to use the variant creation E. So we want to generate one of these. We're going to need to pick a variant, Presumably it's a creation error, so we're going to pick creation. Creation takes as an argument the actual creation error. We were past that right here, so we're going to pass that there, and we should be good. And so that takes care of one of the two things. We will also have, so that takes care of this error here that can come from the new, but we also have parse can return an error, which we also need to convert into a parse pos non-zero error. This name is terrible. And it says here the trait from parse int error is not implemented for parse pos non-zero error. So this kind of suggests using the from. We could clearly use the map error, but this suggests using the from. So let's go ahead and do that. So we'll basically have the same thing. We'll have impl from, but instead of from creation error, we're from parse int error for parse pos non-zero error, fn from e parse int error self parse pos non-zero error parse int e. Boom. And I think that'll take care of it. Now, one thing I will say, again with my refactoring hat on, and I'm just, yeah, I'm a junkie for refactoring. This looks almost identical to that. I mean, they differ only in the types. And that I find kind of irksome. And I don't know if there's an easy way to remove that duplication. Can we parameterize the impl on some error? No. I guess I don't know if, I'm thinking kind of in Java land there would be a super type that is error, and I don't know. I mean, these don't seem to be implementing any error type. Doesn't seem to be like a trait that is like all errors implement this trait. So I don't know what the common piece would be. And we would have to be able to tell the difference between a creation and a parse. So maybe there's really nothing to be done about it, because maybe that's the thing. Because these parts have to be different. There's really no good way to share this out. Because, I mean, maybe you could make a macro if you had a ton of them and you had consistent. Like if you always had name and then name followed by error and name followed by error, then you could probably macro something like this. And then it's been suggested that this error is an excellent macro. Let us look up this error. Oh, I think I saw somebody mention this somewhere. And I don't think I read anything about it, so I didn't know exactly what was going on here. So let's see. Let's find an example. Convenient derived macro for the standard library's error trait. So we would derive error on our error, and then that simplifies writing some stuff because the derived components will just appear. Oh, and we get to add messages, all manner of stuff. Okay, well that's interesting. I don't think I want to mess with this now, but I think I'm going to keep this tab open and come back to that later. It feels like this is a thing I probably want to know more about than I do. So, cool. Yay! So that took care of advanced errors. So we implemented from instead of using mapper, and life is good. Questions, comments before we mark this one as done? Last exercise. This exercise demonstrates a few traits that are useful for custom error types to implement, especially so that other code can consume the custom error types more usefully. Make this compile and make the test pass. Implement a missing trait so that main will compile. Complete the partial implementation of from for parse climate error. Handle the missing error cases in from stir for climate. Complete the partial implementation of display for parse climate error. Okay. So we've got a parse climate error enum, which has empty, badland, no city, parse int, and parse float. We can convert from a parse int error to a parse climate error. We can convert from a parse float error to parse climate error, so we have to fill that in. That won't be at all hard, so let's just do that. Parse float e. Now actually, I don't know. So self here refers to parse climate error because we're implementing something for this type. So self allows us is just another name for parse climate error. So self : parse float works. Life is good. We could have also said parse climate error here, and that would have worked as well. Whatever. Okay. Now it said the first step was to actually implement a missing trait so that main will compile. Does main compile now? Let's get down to main. Wow, that's so much stuff. Okay, main does not compile because the trait standard error is not implemented for parse climate error. So this question mark here is not a happy camper. So we need to from stir for climate. So parse climate error doesn't implement standard error. So we could. Now is that something? Can we just say error here? And it derives it? Is this a guess? No, it didn't like that at all. There's only so we can't do that because it's not something you can derive. So we are going to have to impl it. Poop. Impl error for parse climate error. Boom, boom, boom. And this will presumably yell at me about the things I need to implement. So lots of things are not covered. I need to find out what error requires. Rust. Actually, was that right here? Did I have linked? No, it's a different thing. But I could probably just search for std error. No. Probably typed something wrong. What if I just do that? Oh, I'm stuck in this crate. That's my problem. What if I go here? There we go. std error trait. So an example of implementing. So we impl error for super error. We need a function that takes a source, a function source that takes a reference to self and returns one of these things. We'll key find. We'll grab this function because I'm cheap and lazy. And we will boom, boom. Okay, so we're going to take a reference self and we're going to return an error. And does that work? I don't claim to understand what that does, if it does work. No, it's not happy. Oh, it's a method, not a field. Okay, so I need to stop and think for a second. I'm typing and I'm not thinking. So we need a source. Looks like we have to implement source. You need to click on that. Source is generally used. Okay, so we're moving from one kind of error to another, and we can sort of say it's a this kind of error, but it was caused by that kind of thing somewhere else. And source is going to return an option, so a some or a none with a dynamic error, a reference to something that's dynamic error and has static lifetime. Oh, it says I don't. Two people have said I don't have to implement anything for error. But when I did that, let's try that. Oh. So this is saying that there are defaults implemented here. Thank you. I did not realize that. You learn a new language, and one of the things you got to learn how to read the documentation, and you got to learn how to read the error messages, and this is a bit of the documentation I didn't appreciate, so that's very cool. Okay, so we can have nothing, but now this error. But this is not anything to do. I thought this error was coming from saying impl error, but it wasn't actually. It's actually down here. When we match self, we're going to have all of the cases or a wildcard. I get it. Okay. So we've done. So I think we've done this. So main compiles, because this error is not in main. So I think main compiles, maybe. And then it completes the partial implementation of from for parsed climate error. And we did that one actually. Handle the missing error cases in the from stir implementation for climate. So that's where it's yelling. So, implement a missing trait so that We've done that. Oh, and it even said it is not necessary to implement any methods inside the missing trait, if I had looked. So we need to complete this function so that it produces the correct strings for each error variant. So we've got no city, we write no city name, parse float, we do that. So we're gonna have to like get all of these guys. So we need empty, right bang, F, and I'm sure there's actually a test that they have that tells us exactly what we should be returning here. Empty input, string empty input, comma, and that's going to take care of the empty case. And now we have bad len to handle. Bad len, right bang, bang, F. And what do they call bad len down here? The incorrect number of fields. So, and now we have parse int, and then we're done. Parse int e right bang f error parsing. Oh, what parse int error parsing year? Okay, year. Okay, so I think that may fill in most of the blanks, but we have two tests that fail. Okay, so test empty and test no city fail. Oh, so right here, actually, this parser for climate is incomplete. And we need to return some other, check for some other circumstances and return the desired thing. So empty, for example, test no city, we have an empty string on city and we don't check that, whoa, go away. We don't check that that the city might be the empty string. So I think we could do city underscore underscore if city is empty. Is that a thing? Return error parse climate error empty. Oop, I need a comma. That won't compile. Nope, I don't think. Well, that was no city. I returned the wrong thing here. No city. Oh, only one failing left. Yay! And that is if the length is bad. So we're assuming here that we're getting the right number of pieces when we split. And we don't actually know we're going to have the right number of pieces when we split. So we need to check that. And I don't know. Can we do something like well, I know we could do this. So let's do v.len not equal to 3. return error, parse, climate, error, bad len. So I think that'll fix it. No, it didn't. Oh, it's not length. Not length, it's len. I think I'm going to have to figure out, is there ever a length? Is anything a dot length in Rust, or is it all dot len? And I just need to like remember that. And now everything's good except for this one. So I think if the string is empty, yeah, if the string is empty, then return error, parse, climate error, empty. So I think that'll pass everything. Wah, 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 wah. It does. Okay. Now, question is, can we tidy this up? If the string's empty, if we don't have this check here, this check will think that we have bad len and will return something. So we are going to have to check for is empty first. But can we do that in the match? So could we say if the vector is empty, return error, parse, climate error, colon, empty. And now that'll fail because this test still is going to catch it. But let's see if we take that out, do we only get the bad len error? Only one failed, and it was the bad len error. Okay, so that worked. And now can we do something like, v if v.len not equal to 3, return parse climate error bad len, comma. Does that work? No, it does not. We got an empty and we expected a bad len. Huh? What? Really? No. So this is test. No, this is testing empty. We expected empty and we got bad len. Why did we not get this? Oh, because we actually get an empty string here, I think. Is that true? Is that even going to work? Ho-ho! Yeah, so if we get the empty string and we split, you don't get the empty vec back. You get a vec that has one empty string in it. Because split always returns at least one thing. Oh, okay. So then we can get rid of those guys and everything is in the match. Now, do I like that? I don't know. I mean, it seems like we're kind of beating the match with a stick a little bit, but maybe not. Maybe not. Yeah, I'm not sure. I'd have to think about that more than I'm going to think about it right now. So, but it does work. If we get a vector containing just the empty string, then we'll return empty. If we have a vector, and this would match any vector, but we check to see if the length is not equal to 3, then we return bad len. Now we know, oh, actually, so I could skip the is empty here if I put blank string here, and then I can get rid of this if. Yeah, that's nice. So I've got rid of that if. That's cool. And then if we match city year temp, then we can convert the city to a string, the year and a temp. Anything else we return, we return bad len. Oh, so we don't really need this because this will only match things of length 3, and this will only match things of length 3, and anything else is going to come through as bad len at the end. Oh, and it was annoying me that I had this if. I'd gotten rid of all the other ifs. And I was like, can I get rid of that if? But this totally would work, I think. Yes. Okay. So if we have just an empty string, we return empty. If we have 3 things, but the first is an empty string, we return no city. If we have 3 things, then we convert the first to a string, and then the year and the temp just are unchanged, and we return that triple. Otherwise, we return a bad len error because we had either less than 3 or greater than 3 elements. Hot diggity. I like that. Okay, that is cool. And that, your comment about the order of a match matters, maybe that was what the hint you were trying to give me, that and I just didn't look down far enough to realize that this was catching and returning bad len. I didn't sort of notice what that was doing down there. So if that was what you were trying to say, thank you. Sorry that I didn't catch it. Cool. That is nifty, nifty, nifty. And I think that wraps things up. And I think this will be the last. Any comments or questions? I guess I should scroll back to the code on this. So if I mark that as done, I think this will be the last one. And we will be finished. Yay! We're done. We made it through Rustlings. We hope you enjoyed learning about the various aspects of Rust. I did. Actually, I have looked at a lot of different learning language acts through a series of exercises systems over the past many years. And I think this has been the best one that I've ever interacted with. There were some issues. I still think the quizzes are kind of a mess, and I might propose some changes on the GitHub about that. But I actually have found the Rustlings exercises to be probably the best tools for learning a language that I've ever run across. And that might be partly the language itself. The fact that so much happens in the compiler, maybe you can teach a lot, force people to learn a lot of concepts by forcing them to interact with the compiler in particular ways. But yeah, I found these exercises to be really quite good. So I have actually enjoyed that. And I have already posted a couple of things on the Rustlings repo, and I may want to do some more there. But zippity-doo-dah, that was very fun. And thank you, everybody, who has patiently watched and in many cases shared ideas. Super appreciated. It has been a big help, and I've learned a lot from the suggestions and tips that you folks have provided. So big thanks. So it's 10 till. I think we'll call this a win and move on. I'll mention briefly what I'm thinking of doing next, since we do have a few minutes. I'll pull that up. I'll put the URL for this in the chat in case anybody cares. So I'm thinking of building a tool in Rust that doesn't need to be built in Rust at all. This will not take any meaningful advantage of the awesomeness of Rust. Probably, I don't think. But it'll teach me a lot of Rust in a practical setting and build something that I care about. And so I'm thinking that the next episodes will start with this and go forward from there. And so what's the idea? The idea is I teach computer science at a university, and we use GitHub Classroom a lot. And so classroom.github.com and sign in. Oh, fine. No, go away. There we go. So we use GitHub Classroom a lot, and we get a lot. Oh, actually, it'd be more useful to actually show you. Come on. I thought this. Oh, there we are. Yeah. And you end up with a lot of repositories. So there's 56 repositories, for example, from this course from a couple of years ago. All of those repositories really ought to be archived. Archiving a repository by hand in GitHub is actually pretty tedious. It's entirely doable, but you've got to like click around a lot, and then you have to type in the whole name of the repository to prove that you really wanted to archive it. And to do that 56 times for a course is a lot, right? That's just not happening. So we're not archiving these old course repositories. This is a course from 2 years ago. I've got stuff that's like from 6 years ago. These are repositories nobody's ever going to touch. They really ought to be closed down. It would be better just as a way of communicating with other people that these repositories are done and not going to be messed with again. Also, it would reduce the likelihood that I get random notifications in GitHub about some 5-year-old repository, either because somebody posted an issue on it, or somebody, or there's a dependency problem, like there's a security thing that's been noticed. I don't really need that on old things. So archiving them would be nice. But doing it by hand, that would stink. So my idea is to use Rust and YEW, which is a web app WASM framework, to build a little web app that would, because if you go through the GitHub API, you can archive these things much more efficiently. So my idea is to build a very simple little web app where I can log in, say what organization I want to archive things for. It would go find all the repos in that organization and give me a list of them, maybe with some information about when they were last modified, yada, yada, yada. I could then checkbox the ones I actually want to archive. So if there's one that's been modified recently, I maybe don't want to archive it because maybe it's actually active in a way that I didn't appreciate. And then hit the big do it button, and then it would do the thing. Question in the chat, why do I need a UI for this? I totally don't. You could totally do this as a CLI thing. And in some ways it would probably be more rusty to actually do it as a CLI. My interest in doing it as a web app instead is twofold. One, I do envision like this checkboxy, maybe resort the items kind of interface if I get that far. I don't know if I'll bother because I probably don't need a lot of that. But I have this vision that there could be kind of some nice stuff. And if I need this, there are probably faculty at other institutions that would find this useful as well. So if I do a good job, whatever that means, this might get used by some other people. Not a lot of people, but some people might find it very helpful. Probably more likely to use it if it's a static web page. that I can just point people at. Say, go there, log in, it'll do the stuff. They don't have to install anything. They don't have to, learn how to use the CLI. So that's kind of what I'm thinking, is that might be useful. And frankly, I'd like to know more about WebAssembly, and Rust and Wasm seem to work well together. And so using this as an excuse to do something with WebAssembly is where I'm coming from also on that. So that's my thought. I don't know. You're totally right. You don't need a UI. You could do this without one. You could imagine building a library crate that actually has most of the actual interesting logic, and then on top of that build a CLI interface and a Wasm web interface if one was keen. But I think I'll start off with just build it as a Wasm thing, and we'll see what happens. So, yeah, just see, and there's probably really nothing here that's really gonna benefit from the speed of Rust in any meaningful way. This app will spend most of its time either waiting for the server to give its stuff back or waiting for the user to make decisions. It's not going to be doing any serious computation. So I don't think the blazing speed of Rust is going to matter at all here. And there are probably other more developed tools that I could use for building a web interface. But I'm kind of learning Rust, so I'm going to use Rust and Wasm, and we'll see what happens. And if I hate it, then that'll be the end of that. And if it's cool, then there are some potential extensions that I talk about in the README here. So this is the repo that I'll actually plan on working in. And it's got, this README has basically a lot of ideas that I've had about this. And we'll see how it goes as we get into it. But I have built at least one little Wasm app with you to prove that I could do it. And it seemed pretty straightforward. So I'm hoping that this won't be too bad, and it'll be reasonably interesting. I don't know. We'll find out. So that's probably what I will start with on Saturday, because we have finished the Rustling exercises. So again, it's about 12 o'clock my time, so I think it's time to wrap it up. Thank you all very much. It has, as always, been really useful and helpful. And I hope to see you Saturday and we try to build this thing, or start building this thing. It probably won't happen in one session, but we'll see what we can do. So thank you all very much, and we'll talk to you later. Bing.